In Unit 7, we're going to be looking at a lot of different types of vectors. You've heard of vectors before, and there are two different quantities that we use as kind of comparisons. We have scalar quantities and vector quantities. And a scalar quantity is a quantity that just has a magnitude, like a speed, or if I tell you so many miles, or I tell you a certain amount of force is being applied to some object. Versus a vector quantity is a quantity that has not only a magnitude or an amount, it has a direction in which it's being applied. So maybe a force that you have a certain number of pounds of force that's being applied onto some object, but you also know the direction in which it has the force applied. Or say we know how fast something is traveling, but we also know what direction it's traveling in. That would be a vector quantity. So a velocity is a vector quantity. Now there are a few different common notations to use for vectors. One of those is rectangular form, also called component form. And if I have an example of one right here, think of this as possibly miles. Say I give you a vector which is denoted by these pointy parentheses or arrowheads at each end. And this automatically means that this rectangular form or component form, that there is some magnitude in some direction that we're referring to when we see this type of notation. So I showed a couple of examples here on using this notation. If I see this vector, I actually don't know where the vector is starting. I just know that once I start at a position that I need to move 2 units to the right and 4 units up. Very similar to as if you were going to be graphing a point to 4. So commonly, we have another definition down here for standard position, that if I graph a vector in standard position, we start the vector at the origin and stop it at the point that would be associated with this type of notation, stopping it at the point AB. So I'm going to use that same idea up here. I'll start my vector at 0, 0, and then I will move to the point 2, 4. This is called the tail of the vector, and this is the head of the vector, and the head of the vector has an arrow. Now, unlike rays or angles or lines, when we use the notation in the context of an angle, a ray, or a line, this arrowhead means that it goes on forever. However, in the vector realm, this means that's the end of the vector, and it also would denote that this is the direction that my vector is moving. Right, so this does not mean to continue on forever. So it's very important not to just extend the line or the segment through there. It definitely needs to stop there, and we need the arrowhead shown to show what direction this vector is pointing. Now this vector 2, 4 could have also been drawn not in standard position. I could have decided to start the vector at the point -2, -2, as I've shown in this diagram. Then I would have to move over 2 and up 4, draw the length, and then put the arrowhead to show that that's the direction of it traveling. The magnitude of the vector would be how long the vector is, which I can use Pythagorean theorem to find. And the angle, or the direction that the vector is slanted, there are a few different ways to describe that, but if I were going to describe it as in reference to our positive x-axis and put it in the standard position angle that we've worked with in the past with trigonometry, my good old tangent function would be helpful. I know that the opposite side is 4, the adjacent side is 2, so if I take the inverse tan of 2, I can determine that this angle in degrees is 63.4 degrees. Now, I showed another example over here. I decided to put this vector again into standard position, which was arbitrarily chosen. I do not have to draw a vector in standard position if I say draw this. It's just very convenient to do so. And so if I go right to the left 3 and up 2 and put the arrowhead at the end of this point, I can see this one definitely has a different direction that it's traveling as opposed to this one. Magnitudes don't look terribly different in my diagram, although they are different. Magnitude, Pythagorean theorem, always a positive quantity. And if I want to determine the direction, quite often the easiest thing to do is just to draw a little picture. And I decided not to even utilize the negativity that was on this x component. I just drew my little picture, and I can see in this little right triangle that I have opposite side is 2, adjacent side is 3. I'm not going to worry about the negativity, and I'll just find this little acute angle. Found that to be 33.7 degrees, and then if I want to determine the angle relative to the positive x-axis to talk about direction, then I just take the supplement of 33.7 degrees to arrive at the 146.3 degrees. So drawing pictures of these, it makes everything much clearer for your computations. Now, a few little terms. Magnitude of a vector. If you look up vector notation, sometimes vectors will have little arrowheads over those just to denote that they are vectors. Sometimes they'll just talk about it as a vector, and they'll often put this in a bold print. But anytime we want to deal with the magnitude, the common notation is to put absolute value around the name of the vector, and that's just going to mean how long the vector is. The direction, the angle that it's going to make, either with the positive x-axis or with a bearing angle, would be what angle it makes from north going in a clockwise direction. Bearing would be common to be used in aviation and if you're dealing with anything with nautical theme. As you might expect, a zero vector would be a vector that has a length of 0, therefore wouldn't have any direction, and that would be its notation. Any two arrows or any two vectors that point in the same direction and have the same length would be considered equivalent or the same vector. Now, oftentimes I will give you 2 points and ask you to describe the vector that is formed from the 2 points. And I would always suggest that you draw a picture to see what is happening in this situation. So if I had a vector that I was giving you that is x sub 1, y sub 1, and I tell you that its terminal point, or the arrowhead, is going to lie at x sub 2, y sub 2, draw a picture so that the answer you get will make sense. You can see that to find what its rectangular component or rectangular form or component form for the vector would be, is I would definitely want to find how far I need to move horizontally to get from my initial point to my terminal point, and then how far I have to go either up or down to get to my terminal point. And this will be a computation of taking the difference in the x's as the x component and the difference in the y's to get the y component of your vector. So it's called a head minus tail rule, although I'm not going to suggest that you memorize it as head minus tail rule. I'm going to suggest that you draw a picture of what you have and make geometric sense out of it. If you subtract these 2 x coordinates, you will find that you're going to figure out this distance, and if I take the difference in the y coordinates, I will find how far up or possibly down I had to travel to get to that location. And that's it for page 1.